All right, so here's our rotation that we read out of the machine. Okay. What we're going to do is we're going to divide that by the length times the concentration. Okay. Concentration is a little bit of an unusual. It's not molarity, okay, like we often use. It's grams per ml. I mean, I think actually there might be specific rotations. You know, there's different ways you can set this up. You know, there's different ways you could decide to do a molarity. But you just have to make sure that whatever literature value or whatever other value you're comparing to, set it up the same way. So that's a reasonable comparison. Okay. This is most often a decameter. Yeah. So that's cell length in decimeters. Okay. Concentration obviously. Okay. And then this is specific rotation. Okay. All right. So your units for this will end up being degrees, milliliters over grams, right? You flip that, okay, over deciliters. Okay? All right. Almost there. Okay, so to recap, you want ratio. Okay. You can get it from percent EE. Okay. Where get percent EE? Where are we going to get that? Okay. Well, percent EE is directly equal, conveniently equal to your specific rotation divided by the lit specific. Yeah, no, that's right. Rotation. Convenient, right? So you're going to get your rotation, okay, up here. Then you got to convert it to specific rotation by knowing the concentration. Well, you're going to make the sample. You got your vial. You're going to put in the volume of methanol. Okay. So you're going to put in 2 mils. Okay. You got to figure out how many grams. You can do the subtract. You know, you weighed it last week. You go weigh it on the balance this week. Get your grams. Okay. That's 1 decameter. We always do that so that we don't got to bother so much with it. Okay. And then in the worksheet itself, it's got the literature specific rotation. Pay attention to sign, right? What does sign indicate? It can rotate plus or minus. Okay? What's the relationship? What do I know about if one of them rotates plus, what does the other one do? What's that?
rotates minus.
It rotates minus. Yeah, exactly. Okay. All right. But there's a wrinkle. Small little wrinkle. You're probably thinking there's enough here. We didn't really need a wrinkle. Okay, what's the wrinkle? The wrinkle is that almost guaranteed your reactions didn't go to completion. Okay? So you have some ethyl acetoacetate in there. Okay? If you take, so maybe you go up there and you do your subtraction and everything like that, and you find that you have 200 milligrams of product. Okay? You can't put 200 or 0.2 grams in this equation because not all those 200 milligrams are your product. Okay? Don't worry. So we got to figure out what's the ratio of ethyl and another ratio. We got to figure out how much, what is the mass percent? What percent of that mass of my 200 milligrams is ethyl 2-hydroxypropanoate? Okay? That make sense? And that's where we're going to use NMR. Right? NMR is going to tell us the whole purpose of using NMR is to figure out what's the mass percent. How much of that 200 milligrams, or whatever you end up getting. You might have 127 milligrams or something like that. I don't know. Okay. Oh. So third and final section, not much here. Need mass of your alcohol product, enantiomer products. It's a mixture of the two enantiomers, but you need to know what that mass is so that you can plug it into that formula that's just right here. The grams over mLs. But there is some unreacted starting material. Okay? If your crude is 0.200 grams, not all is alcohol mixture. Okay? We gotta know what percent of that is alcohol. Maybe it's 90%. Maybe it's 50%. By the way, we don't care. So if it's 50%, if it's 30%, don't be sad. Okay? No mass percent. Okay? Whew. So NMR, if I compare the signals for the starting material and the product, will tell me the mass percent? No. Almost. NMR, if you compare the signals, you got to pick a signal on each molecule. Okay, I know that signal is from the ethyl, the starting material. I know that signal is from the product, and compare the integrations. Oh, 50-50 integration. Oh, no, this one, if I add up the total value and then figure out this one is 80% and this is 20%. Okay? By the way, it's important when you're picking two signals. Oh, I'm going to pick that signal. I'm going to pick that signal. It's important. Pick a signal that's worth the same number of protons on the molecules. What I mean by that is, if you're using a methyl on your starting material, use a methyl on your product. If you're using a CH2 on your starting material, because that'll throw it off, right? You can do the math. You can do the math if you want to compare a methyl. If you just like, this lacks too boring, I want to challenge. But, you know, I would compare CH2s to CH2s and CH2s to CH2s. And there's a hint in the worksheet of which ones you should choose. Okay. So you pick a CH2 to CH2 or methyl versus methyl, and then you compare their integrations. They don't give you the mass percent directly. What they give you is the mole percent. They give you the equivalents, okay? Because they're different molecular weights. All right? NMR is a function of how many molecules are in the solution, not a function of how much mass is in the solution. Does that make sense? Okay? But in the worksheet, there's a very easy trick. If you know the equivalents, there's a very easy trick in the worksheet on how you can turn that into a mass percent. It's basically, well, okay, I know what the equivalence is, so I'm going to pretend I got 10 grams of starting material. I'll figure out how many moles that is. Integration gave me the equivalents, so once I know the moles of this guy, I can figure out the moles of that guy. Because I know the molecular weight, I can figure out the mass of that guy. I can add up those two masses and then come up with the mass percent. Does that make sense? Yeah. Okay. Just read the work, read the thing 3 times. Need to know the mass percent. NMR of mix, by that I mean integrating a signal from starting material versus product. Okay. By knowing the, always bothers me when I write that, even though everybody in the world, it's really molar mass, but anyway, I like the way, sorry, of each product starting material. You can calculate the percent mass from mole ratio. Okay? So you go through that process and maybe you'll decide that you're, oh, it's 70% alcohol product and 30% starting material. Then you take that 200 milligrams or whatever, and you multiply that by 70%. Okay, you'll get 140. Now you can figure out your specific rotation by plugging it into grams of product over milliliters of solution. Any questions? Outstanding. Okay. Yeah. I'm sorry. Does anybody need the